This is session 4, sampling the historical web and temporal resilience of web pages. In order to study the web, we need ways to understand key characteristics of a website over time and in the context of its web archive. And the two panelists in this session today will share some approaches to this need. All of our panel is coming to you from Virginia in the US today. Kritika Garg is a fourth-year PhD student in the Department of Computer Science at Old Dominion University and a member of the Web Science and Digital Libraries Research Group. And she will talk about the strategies and lessons learned from sampling the web and collecting 27 million URLs with 3.8 billion archive pages spanning 26 years of the Internet Archive's holdings. And our second presenter is Dr. Sawood Alam. Sawood is the research lead of the Wayback Machine at the Internet Archive. And he will talk about Trend Machine, a model for tracking resilience of web pages over time using their archival records to explore the research question, how healthy has a web page been throughout its lifetime? The videos for these presentations were available in advance. And while I hope everyone has had a chance to watch those, it's okay if you haven't had a chance. Each speaker will be giving a brief recap of their presentation. And after our speakers give a short summary of their presentation, we'll follow that up with discussion and questions from our audience. If you've been in the session so far this morning, you kind of know the drill, but if you're just joining us, we encourage you to share your questions at any point using the Q&A feature in the Zoom. The sessions are recorded and they might be published, so you can ask questions anonymously as well if you prefer. And if you see a question that you're also interested in, please upvote it. That will help me prioritize questions. All right, so we'll start with a recap from Kritika.
Hi, thanks, Laura. So in this work, we discuss how we employed various sampling strategies to curate our representative sample of the web and lessons that we learned from this sampling. Our final sample contains time maps of 27 million URLs, comprising almost 4 billion archive pages from 1996 to 2021. Our initial motivation, our overall project goal with this sampling was to revisit fundamental questions regarding the size, nature of publicly archivable web, and in particular, to reconsider how long does a web page last. In this work, we proposed several dimensions to sample URLs using the archived web, such as time of first archive, HTML versus other MIME types, URL depth, like root pages versus deep links, and then TLEs, etc. This work is one of the outcome of collaborative project with ODU, Internet Archive and Protocol Lab.
Thank you for that summary, Kritika. And next up, Sawood.
Hi, I'm Sawood Alam from the Wayback Machine at the Internet Archive. And I hope you watched our presentation. And I will go with a little demo of the system. So this Trend Machine is an outcome of a collaborative project from the Old Dominion University, Internet Archive, and Protocol Labs. And in this system, we try to assess the health of a web page over its lifetime. So take the example of example.com. We see there is a resilience score that is pretty high throughout, but there was a period where the resilience score gone down, and in this period it was redirecting to a different URL altogether, not a canonical form of the same URL, but somewhere else. And then it became stable again. Since then, it's been doing great. We see a trend line for fixity. Example.com is a pretty static page, so it doesn't change a lot. That's why fixity score is pretty high throughout. Towards the end, there are some changes in this region. That is because it's not because the content is changing, but because sometimes we download their compressed data, sometimes we download their plain text data, depending on which crawler we use. So that changes the content digest, basically. And then we have chaos score that also helps us identify interesting points of interest, like when HTTPS adoption happens. So a lot of consecutive requests will go from HTTP to HTTPS, or some of the canonical domain changes happen. There are some other interesting features that this chaos trend line kind of captures. We also see that the example.com has been archived consistently throughout, and in the recent year, it has been archived more often than not. And there are a bunch of other statistics that you can see about any web page you enter in here. There is a side-by-side comparison of the first and last captures. And here is the live site, what it looks like right now, and the HTTP headers that it returns. So the example.com is pretty boring, right? Here is another one, geocities.com, and you see the trend lines are going up and down in many different places. The point of this portal is to not every capture is created equal, right? And finding out like where are the interesting pieces that you should be looking for. So if you are analyzing or doing some research, perhaps this is a good region to look at, right? There is something is changing. What was going on here? What happened here? Like, and these are a point of interest in this case. Also, when you combine features like resilience and fixity, so high resilience in this region, but at the same time, low fixity in this region, this kind of indicates how news web pages like their landing pages behave, where the page will be very healthy, it will be returning 200 OK all the time, but the content keeps changing each time. So the fixity is not that great, right? So these kind of categorization people can do on this data. Now, how these graphs are generated is basically we use sigmoid functions to model this behavior, where there's shift value, slope, and spread. You can adjust these for all these 200, 300, 400, 500 response codes, and a composite effect of that sigmoid function will basically give you these curves. So now think about it, like, and this portal is giving it data for one URL at a time, and Kritika just mentioned about sampling the web. You take those 27 million URLs and apply this model on that, and you have a very good idea of how web was performing over the years. So that's it, and I will take any questions from there.
Thank you both. So just a reminder to everyone that you can put your questions in the Q&A section of the Zoom. As folks are kind of warming up, a question for each of you. So your sampling approaches, Kritika, and the sigmoid functions that you talked about, Sawood, help us understand the web or a website over time, but they also tell us something about the archive whose indexes you're analyzing. And I was wondering if you could each say a little bit about how your results in your research tell us what they tell us about the archive you used, and how the results might be different if applied to a different archive. So Kritika first, and then Sawood.
So we sampled in Internet Archive's ZipNum index file. This file contains like every 6,000th line of CDX index. It contains all kind of URLs like embedded resources, images, CSS. So we had to, what we learned is you can correctly predict HTML pages based on extension. We also saw how both web and archiving capacity has increased over the years. And we had like fewer URLs in earlier years. But when we looked at the later years, what we found was that percentage of the deep links archived compared to the root URLs had increased over the years. We also saw that it was challenging to ensure the fairness in the domain representation using web archives. We found that our initial sample was dominated by long tails, domains with only one URLs. But on the other hand, we also saw some popular domains such as like Yahoo, Amazon, Twitter, which were overrepresented. So we had to employ different techniques to ensure balance in our data set. And we use IA's index file, which gave us some insights into their archival holding. And they also provided us with the like large amount of archive web spanning like 26, 27 years. If this study were to do with any other web archive, I think that initial sample will be affected, like and the temporal representation that we have for 26 years, that might be affected. So but we might see some new challenges also related to the new archival holdings. But that being said, the strategies that we use are applicable to most web archives or any web archive having CDX index files.
Thanks. And so
I'd say the system trend machine is while it is being tested on Internet Archive CDX API, it is really any archive that has a CDX data can instrument it to use it online or as a command line tool, just reading the CDX data, which is a pretty standard format. Most of the archives have that. The only caveat I would mention here is if the archives who are using it, if they don't have enough captures of the same URL, then you can't say much about it. It's no different from, say, someone observing your pulse, like heart rate or something like, once, and then say how healthy or unhealthy you are, right? And so if there are like enough historical records of someone's like health data, their heart rate, their blood pressure and whatnot, we can say a lot more about it. So this will be more useful when there is more, when the temporal spread is larger and there are enough observations throughout. Otherwise, the code is open source. People can go and explore it and see it. I actually posted links in the chat.
Great. Well, we've got some questions starting to come in. A question for you, Sawood. What data structure do you need to use the trend machine? Do you need to do a lot of processing of the archive data, or do you need CDX files to be formatted in a certain way? This is a question from Megan Lyon.
Yeah, so I think I partially answered that. We are using CDX data. I think 9-column or 11-column CDX data should work fine. But if it doesn't work that way, slight modification will make it work. We are only relying on CDX data at this point. CDXJ support is not there, but one can very easily convert CDXJ into CDX and use that. There is no head of time calculation or anything. We just ingest a stream of CDX and generate results from there. Internally, we are using data frames and all to calculate statistics, but that's part of the implementation.
Thanks. Let's see. Can you tell, this is an anonymous question, can you tell which ISP and DNS company the domains came from when you see trends?
So unfortunately not. I mean, this can be instrumented. The problem is a lot of that data is buried into WARC files and was never indexed. So when crawlers crawl these web pages, they do try to download DNS lookup and the records are stored. It's just that those are not indexed, and so it's not easy to find it. If someone creates CDX files on their WARC files and index DNS records, then sure, this tool can be instrumented to show that information as well.
I have a question here from Thun Vandedol. Great presentation. I really like the video. At 6 minutes, 30 seconds, your slide lists Schumrubber Gigant, a website in the Netherlands, the .nl domain. Being from the Netherlands, this seems like a typical landing page. To me, did you specifically try to identify these? That said, at least this is a real site right now. And I'm not sure I don't remember which video this was in, this particular .nl website. Was that yours, Kritika?
I think this might be for me. So as long as I remember, I think it's it's one of the domains that we removed for having just one URL. It's one of the domains from the long tail. So we did separated like root URLs and deep links. So the reason that like we just identified that it's a root URL, but we did not specifically but the reason we did not kept this was that it's not a So when we say it's a domain with a long tail, we meant specifically what we found in the Internet Archive's CDX file. So in that particular file, we only had like one URL for this domain. So that's the reason we had to remove it, even if it's a real site currently.
Mhm.
I hope that answered
So-
your
so-
question.
So I would add to that just a little bit. Like, I mean, the rationality behind removing long tail in some cases was basically so that we don't have the data set too large. Like, if your sample contains everything, then it's not a sample, right? and the purpose of this study was eventually to find out age of web pages, like average age or health and whatnot. And if there are pages that have only one or two captures, there's not a lot you can say about it. So we basically trim those things off in most cases, so that pages with more captures are overrepresented. Now, it doesn't necessarily say that the page is not important, not. It's how web archives see it and how often they archived it that also kind of plays this a big role in sampling.
I see that Langdon he has clarified his question that he meant landing page, as in people like them being redirected to that page. So yes, we are now so we have created this sample, right? And now we are still working on it and trying to get more insights out of it. So we did saw few of these landing pages or sinks, which where like a lot of our URLs are where a lot of different URLs are redirected to a similar page to a single page. So yeah, we are now like investigating them further, these kind of URLs.
Thanks for that follow-up. I have another question for you, Kritika, from Megan Lyon. In the presentation, you spoke about an increase of web archiving capacity over time, saying deep links increase. And could you clarify that some more? Does deep link mean one with a long path, or what's the cutoff for deep, and what are the implications of that finding?
So in our work, we have categorized it into two: root URLs and deep links. So deep links is anything with more than zero path, like with the long path, like you said. And we also took out all the URLs with like /index.html. So if something is like foo.com/index.html, those are usually the root pages. So yeah, except for the root pages and pages like these, we are calling everything else as a deep link.
We've got another question here about, you mentioned that a page lasted 44 to 100 days on average, according to 1990s researchers. Has your research shown how long does a web page last nowadays?
So this work was specifically about sharing how we curated the data. We are working towards that number, and we are learning how many, like it comes with lots of warnings and its own challenges.
So that may be what's coming up next in your research, is to work towards it, looking at that. Sawood, what's next in your research?
Oh, so this one is basically using this this trend machine stuff and applying it on these millions of URLs that we have identified, and we have already ran it in a kind of now we are looking into that data set to be able to cluster sites with similar nature and that have similar behavior and whatnot. I mean, the question, the 40-day or 100-day question that was asked, it will be answered using this trend machine thing. And I think we have also kind of, introduced this twist in this, like, I mean, sometimes just knowing average lifespan of a web page is not very useful. Maybe we should be talking more about health over time of these pages. So that is an interesting question. We have think, is it a useful one, right? So yes, keep an eye. There'll be a research, something like not your parents' web, and that will seek to answer some of these questions.
Thanks. I've got another question about Trend Machine. One of the potential use cases that you mentioned was archival quality assurance, and QA is definitely a topic of interest to many people involved in web archiving. Could you say more about that possible application of Trend Machine?
So yes, so if you've seen the trend lines like going up and down, that is basically where, so the problem of QA is like there's a lot that you can QA, and sometimes you can archive way faster than you can quality assure those things. So picking and choosing right spots like where to QA, or kind of sampling your captures, is where Trend Machine can help. And as you asked before, like what is next? So another potential feature that we plan to add is human can decide what they want to look at, but what if we put some logic, heuristic-based logic, like, okay, this score is going down, that other score is going up, what could possibly be happening here, and how well it was archived in this region and whatnot, and come up with human-readable summaries that just brief the overall situation of the page based on these numbers, and allow people to explore further, but kind of things that we already understood based on the behaviors of different pages, we can say it out loud. So that will also help people who are trying to do quality assurance, like try to check something. Say CSS is missing, how that affects certain things, right? And at some point we might also include live thumbnails or embedded views on certain spots where things are changing, so that people can visually see, oh, something's wrong here, and what is going on, right? So we can look into it further.
Yeah, that sounds like it'd be really cool to see. A nice way to sort of visually, additional visual way to understand the way the site changed over time.
I would want to clarify or add to a little bit of like, why did we divide this, what Kritika was talking about, why did we divide the data set into root pages versus deep links? I think the reason was, more often than not, when we say, hey, how well example.com is archived, we generally, the root pages or the landing pages of websites, they are archived more often. And sometimes people look into those more often than deep links. But if you are talking about CNN.com, the homepage versus an article URL of the CNN.com, if we try to average lifespan of both, it will go drastically in one way or the other, and the results might be skewed. So it is helpful to have them separate and analyze home pages separately from deep links. And that's why basically we introduced this concept of segregated sampling.
Thanks. Is there anything else you'd like to say about the deep links, Kritika? There was a follow-up question as well from Megan about, does capturing more deep links mean crawlers are getting better or crawling more thoroughly on a given site, or is it the nature of how sites are designed and they are deeper? What are sort of your takeaways from seeing these deep links?
I think it's both. The web archives are getting better, and also the web in general is have more deep links compared to what we will see in 1996. Looking at the deep links, we also saw this with our work, like when we looked at like the popular URLs in 1996 or like the earlier years, we had more root URLs. But now that we see popular URLs of the recent years in our sample, we found it was deep links, and in fact it was like service or framework URLs. So yeah, deep links are getting more, on the web.
Yeah, so something to consider if it's.
There is only how many root URLs there are. There are more deep links than those. So I think their overall prevalence is increasing. So they're also kind of making their way into archives.
Well, thank you both, and thank you everybody who submitted the questions for this panel.